All right. Got your exam back. I'm going to answer key posted this afternoon for that as well. So if you want to come in and go over things that you missed, I'm happy to do that always. Remember, at the end of the semester, this is a pass-fail class, so you have to have a 70% course average to pass. Below that is a fail. Just reminding, since advising day is tomorrow. All that good stuff as you're planning forward. All right. Anyway, let's talk about new stuff. So we've talked about solving equations in the past, where we factored or set everything equal to 0 and factored and then set each piece equal to 0. We've done that before. We even did that with radicals, and we also simplified some things with radicals in them. We simplified radicals assuming everything was a positive value. And the reason why we assume everything is a positive value, because ordinarily, at least for real numbers, we can't take the square root of a negative. The reason for that is because, of course, if I square any number, or if I take a negative times a negative, I always get a positive, right? So what are all these weird things on the board here or on the screen and on your paper where we've got square roots with negatives underneath them? Well, this is where we come up with what we refer to as complex numbers, and they pop up from trying to solve equations. So in particular, if you look at this equation in particular, this x squared plus 1 equals 0, well, if we think about it for real numbers, this doesn't have any solutions at all. Because again, if I put something in for x, it doesn't matter if it's positive or if it's negative. If I square it, if I multiply it by itself, it's always going to be positive, and then we add 1. Right? So it can never be 0. So this is when we introduce what we refer to as the imaginary unit. So notice if I were to try to solve this equation kind of a brute force way, you would subtract 1 from both sides, and then you would take the square root of both sides. Anytime you take the square root of a negative, anytime you take the square root of both sides of the equation, you always get a positive or a negative value. And notice we've got a negative 1 under that square root sign. I have this now solved for x, but from a real number perspective, this doesn't make any sense. So we call this square root of negative 1 a special thing. And we see that on your notes there. But the square root of negative 1 is called I. And we refer to that as the imaginary unit. Lots of things in mathematics get bad names because when they were discussed or discovered, they weren't thought of as being useful. Okay? So, for example, the reason why we call numbers negative numbers is because when they were first discovered back in ancient Greece, they didn't make any sense for a practical purpose for negatives. Now we know we can use them to represent displacement from an origin, positive or negative. We use them to represent balances in checking accounts or balances on credit cards, right? But back when they were first discovered or first talked about by a Greek mathematician named Diophantus, he referred to them as absurd. The only purpose for him was that they got solutions to equations. Okay? But you see this in other walks of math. Irrational numbers, right? Those didn't make any sense because you could construct them from sides that were integer length. That was where they come from, right triangle ideas. So those didn't make sense to them, so they called them irrational. Or if you have a fraction with a number on top bigger than another, you call it improper, right? Lots of negative connotations of things in math that really aren't negative things at all, right? Imaginary is another one. When imaginary numbers and complex numbers first came up, was literally only to try to write down solutions of equations of this form. Solutions to equations that didn't have real number solutions. However, going forward now, we see applications of complex numbers, in particular in engineering, anything that has, they're trying to describe anything that has a wave pattern to it, complex numbers pop up. So electronics, magnetism, any of those kind of things, imaginary numbers play a huge role in that with modeling. So just because it's called imaginary from a mathematical perspective doesn't mean they don't exist. Okay? Even though it has the word imaginary in it. All right. However, the imaginary unit, or the I, we always think of that as square root of -1. Or if you square both sides, when we square both sides and get rid of the square root, we get I squared is equal to -1. So in particular, anytime we see an I squared, later on when we start doing some multiplying with these things on Wednesday, anytime we see an I squared, we'll replace it with a -1. Okay? So these first few problems that we have here talk about trying to simplify radicals when we've got a negative under the square root. Okay? This one is these are going to be just like what we were doing with simplifying radicals before. There's just going to be one extra step, and you're going to do it in the beginning. Whenever you see a negative under your square root, you're going to rewrite it so that you have an I. Okay? So what I mean by that is, if I think about it this way, you can think about it as square root of -1 times 4 to start with. Right? -4 is the same thing as -1 times 4. Right? And remember, we kind of broke up things into pieces when we were doing, when we were simplifying radicals before. When we had variables and numbers and we were doing things. When I simplify this part with this -1 being under the radical, the very, very, very first step should always be make that negative and put an I instead. Because remember, again, square root of -1 is the same thing as I. So when I'm taking care of this -1, square root of -1, we replace it with an I. Just like when we did things like we had the x squared under there, we made it an x when we took the square root of it, right? Or if we had a y to the 4th, we made it a y squared. Same idea here. I've got a -1 under the radical. When I pull it out, I make it an I. Okay? Now that I've done that, I can simplify the radical that's left just like what we were doing. What's square root of 4 equal to? When we do square root of 4? It's 2, right? So we just get 2i when we're done. So when you're doing these to simplify them with negatives under the radical, first step, replace the negative with an I, then do your radical simplification. Okay? This is very important, by the way. We're going to talk about doing multiplication with these things later. It is very, very important that you simplify the negative under the radical first before you try to multiply anything. Okay? It's very, very important that you do that step first. Okay? So, take care of the negative in the next one. We do the square root of the negative makes an I. So instead of square root of -36, we'll write it as square root of 36 times I. And then simplify your square root of 36. What is square root of 36 equal to? 6. Good. So we just get 6i when we're done. This okay? Okay. Next one, same thing. What do we do first? What do we handle first? The negative. And we'll write this as square root of 18 times an I on the outside. Now, square root of 18 doesn't simplify nicely like the first two do. But can you break down 18 into something you can take the square root of? Let's make our factor tree. What multiplies to give you 18? 9 and 2. And 9 breaks up into 3 and 3. And do you see a pair? 3s. So square root of 18 is the same thing as what? 3 square root of 2, and then the I is on the outside. And be careful in every single problem that you do, every single problem that you're going to do, the I will always be outside of the radical, not inside the radical. Okay? So notice even down here, in this problem here, right below it, that square root stops on the 7. The I is not underneath the radical. You will never, ever, ever have a problem where the square root is over the I. Okay? I'm only saying this because you might type this answer into Hawks. Make sure that when you type it into Hawks, if you've got an I, make sure it's not under the radical. It's outside the radical. Okay? You will never have anything, I promise you, you will never have anything where the I will be under the radical, ever. Okay? All right. Now, a lot of times, actually, and I'm going to mention this here in a second, there's usually people will write these in a different form so you don't get the fact that the I isn't, you won't get confused and think the I is supposed to be under the radical. Okay, I'll talk about that here in a second. All right, so everything that we've done so far was simplifying. We've only had a single term that pops up, right? The first one we saw 2I, the second one we saw 6I, the last one we saw 3 times the square root of 2 times I. But there might be pieces that don't have an I in them. Okay? So well, typically when we have a complex number, there will be a part with an I and a part without an I. Okay? And we'll write it as a sum of two things. We will always put the part that does not have an I first, and the part that does have an I second. So it'll always have the form number plus number times I, if there's two pieces. Okay? So that's what this A plus BI means. This is the part where without the I, we typically refer to that as the real part. No I's, so it's not imaginary, so it's real. Okay? The difference between the real and imaginary, right? Told you that, negative connotations. Okay? The part that does not have an I in it's the real part. The part with the imaginary part is with the imaginary number is the imaginary part. If a problem asks you just for the imaginary part, it means leave off the I and look for the coefficient. Okay? So in this first example, down here, the real part is 4. The imaginary part is square root of 7. It's not square root of 7i. Okay? When we say imaginary part, we're just meaning the coefficient on the I. Okay? So for this first one, real part is 4, imaginary part is square root of 7. Let's look at the next one. What's the real part in the next one? 2, good. How about the imaginary part? Okay, so notice that we've got a minus sign in this case, and the standard form is a plus BI. So it's not just a 3, we have to make it negative 3. Yep. So if there's a minus sign there, it'll be negative 3. In the last one, all right, look, we have this whole thing all over a 5. So if you want to identify the real part and the imaginary part, I've got a 2 over 5, and I have a root 7 over 5. So that 5 is going to be included in both parts. So if you want to think about it this way, you can rewrite this as 2/5 plus square root of 7 over 5i, like that. Notice it's like doing your common denominator in reverse, right? If you added these two together, you would get this, wouldn't you? Did you have a common denominator? So we're splitting it into two pieces. Now looking at it this way, what can you say the real part is? 2/5, good. And the imaginary part? I think it's a 7, right? Square root of 7 over 5? Yeah, but that's exactly right. Good. That's an A. Questions on that one at all? The only reason why I'm breaking that up like that, a lot of times in Hawks, you will be asked to write your answers in standard form. So that imaginary part really wants a number times I on the end. It doesn't want a complex number all over a single value. It'll want it split up versus put all together. No reason why I'm mentioning it. What questions do you have on that? All right. So the next part, actually, what we're adding is subtracting. This is stuff you've already done. You do it exactly like you do with polynomials. You combine like terms. So if you treat your I like an X, it's just like what you do with polynomials. So what would you get when you take 5 plus 3i and add 2 minus 6i? What are you going to get? Good, 7 minus 3i. Good. Because your 5 plus your 2 will give you your 7. Your 3i minus 6i gives you your negative 3i. You handle it just like you do with polynomials. Nothing different. Literally exactly the same thing. I guess the only thing that's a little bit different is typically with polynomials, you write your x first, don't you? You usually would write the x term first and then the constant. Complex numbers, the imaginary part always goes second. All right. Same thing with the second one here. What should I do with this minus sign here before I do anything else? Distribute it. So on the end there, you'll get a minus 3 and a plus 4i. And now what do you get when you simplify? 5 plus 6i. Good. Questions on that? Is that okay? All right. So let's see if we can put some things together. And then I'll turn you loose on the worksheet. This one's asking us to simplify the following radicals. So first up we have square root of 100. Square root of negative 100. What do we handle first? The negative. And make it. So what should we write next step here? And times the I. Good. Exactly right. So square root of 100 times the I. Good. And then the next thing we want to do is take the square root of 100 if we can. Simplify it as much as we can. What is square root of 100? 10. So we get 10i when we're done. That okay? Now let's do square root of negative 80. Again, first step. What's the first step? Okay, we'll do that first here in a second. But the first step always, anytime there's a negative under the radical, first step is what? I. Make it an I. I cannot emphasize that enough. Okay? If you don't do that first, what we're going to do next time when we multiply, you're going to mess things up. Always, 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 always make the negative under the radical into an I. Very first step before you try to even do anything else. Okay? Cannot emphasize it enough. Right? Because what happens, I'll just go ahead and tell you what happens. if you have two negatives under the radical and you multiply them together, when you do the negative times the negative, it becomes a positive, and you think the thing went away. It didn't. Okay? So if you don't make it an I first, you will, I promise, you will mess it up every time. Okay? Make it an I first every single time if there's a negative under the radical. All right. Now let's worry about the 80. Now with the 80, we don't know what square root of 80 is, so let's break it up. What multiplies to give you 80? 8 and 10 does, good. 8 is 4 and 2, which is 2 and 2. And 10 is 2 and 5. Yep, I got a 4. I got 4 left over, don't I? Because I got 2 pairs of 2s. Okay, so we'll have 4 square root of 5 and then an I. Now, I mentioned this before and didn't actually write it down. If you're writing things down for yourself, a lot of times you'll see people write it this way and put the I in front of the radical, and that way you don't get it screwed up and think it goes under the radical. Okay. So writing 4I times square root of 5, it's a little bit nicer way to write it, just so you're not asking yourself, is the I under the radical or outside the radical? If you put it in front, there's no question it's in front of the radical. It's outside the radical. Does that make sense? All right. Let's see if we can do these last two together. I think there's just 2, yes? Yeah. This one's asking you to add and subtract, but again, cannot emphasize enough, what should you do first? Make them an I's. Good. Very, very first thing you should do before you do anything else, if you see a negative under the radical, make it an I. Okay? So the first one becomes what? Good. 2 plus root 49I, and the second one becomes the root 81 times I, right? Do that first. Every single time, do it first. And now let's simplify the radicals. Square root of 49 is 7, and square root of 81 is 9. Good. And now this looks like just adding polynomials, doesn't it? Just with an I instead of an X. What do you get when you add those together? Good. Work on that last one for a second, and then we'll chat about it, and then, like I said, I'll turn you loose on the worksheet. That 4 plus 10I and 8 minus 18I. Now it's minus, so what do we do with the minus sign? Distribute it, good. So we get minus 18, or excuse me, minus 8 plus 18I. So finally, at the end here, you get what? Is it 12? I think it's 4 minus 8, isn't it?
Oh, I put the parentheses.
Yep, it's all right. So it should be minus 4 plus 28I. So what have I got? All right. So go ahead and work on the worksheet. I'll get answers posted up here, projected up here. And